Okay, here's the final review in the flesh. This packet is your notes. Okay, the original price of an item is $30. The item's marked up. Remember, up means plus. What's the new price of the item? Up 20%. What's the new price of the item? So with this plus right here, that means we go original times our percent equals our new. Okay, so I know what I have to do with my percent. I got to take 100% and add 20%. So that's 120%. Remember, that has to be divided by 100 before I put it into the equation. So 120 divided by 100 is 1.2. Okay, now about the 30, it says clearly in the sentence that that's the original price, $30. So to find the new, you simply just multiply 30 times 1.2, and that gives me 36. So $36 is my new price. It's X, $36. Okay, number 2, an item's marked 40% off. Its new price is $48. Find the original price of the item. Okay, so we have the original, the percent, and the off means minus, okay, and the new. Okay, so I know I'm going to take 100% minus 40%, and that's 100 minus 40, 60%. But if it's a percent, it has to be divided by 100. 60 divided by 100, 0.6 for my percent factor. It says its new price is $48. So $48 is a new price, and I don't know the original. So I can't multiply. I have to divide to get back to the original. So I extend the line. I just put 0.6 underneath. Then I divide 48 by 0.6. Okay, 80. So X is 80, and it's $80. Okay, number 3, 70% of the town voted in the election. 200 people voted. How many people are in this town? Now this time, unlike here, there's no word that indicates plus or minus, so I set up a part-whole proportion. So part-whole. Now the part has to be defined by those that voted. Okay, so 100% is the denominator. And then 70% is the numerator. And then read the sentence with the 200. It says 200 people voted, so 200 is my part, and X is my whole. So I cross multiply and divide 100 times 200 divided by 70, and that gives me 285. I'm going to say it's 286, okay? So 286. Okay, and it's 200 people, so 286 people. Okay, my next one, 25% of the students in the school are in band. The school has 240 students. How many students are in band? Okay, again, no word that means plus or minus, so it's a part-whole percentage. Okay, so the part has to be defined by in band. Okay, 25% is the numerator here on the percent ratio. And then read the sentence with the 240. It says the school has 240 students, but it doesn't say they're in band, so that's not the part. 240 is the whole, and X is the part. So I cross multiply and divide. 25 times 240 divided by 100 is 60. Okay, so 240 students, and there'd be 60 students in band. Okay, now the next part, exponents. These ones are easy. You just go 6 times 6 times 6. That's 216. This one here, you take negative 5 times negative 5 times negative 5 times negative 5 on a calculator. 625. Okay, negative 5 to the third this time. Negative 5 times negative 5 times negative 5. That's negative 125. Okay, 3/8 to the third power, so you got 3/8 times 3/8 times 3/8. You multiply the 3's and the 8's. Okay, so 3 times 3 times 3 is 27. That's the top. And then 8 times 8 times 8 is 512. Okay, 27 over 512. Okay, now expressions with variables and exponents. So, underline your expression. If it's not already, if there's not a line there, then circle the parentheses. Okay, so that's a 2 outside of there. Now I have a number 5 and a letter M. So my 5's power would be 1. Now that's in the bubble, so I need to take 1 times 2. 1 times 2 is 2. Okay, now M. Now there's two M variables. Here's the first one. It's to the 6th power, but since that's in the parentheses, because I circled it, 6 has to be multiplied by 2. I cannot just write 6 down, okay? 6 times 2 is 12. So I write down 12th power. And then my other M is on top of the line, so it's plus 3. 12 plus 3 is 15. Okay, now here are my two factors. They're both positive, okay, so they both stay, okay. They don't go to the other side. They're both going to stay. They're both on top. They're both going to stay on top. And then the last box is for the cloning. Okay, you can clone 5. 5 times 5, and that's 25. So that becomes 25. And the other factor stays M to the 15th power. Okay, the next one. Underline, circle the parentheses. Negative 3 is the parentheses power. So any power in there has to be multiplied by negative 3 before I write it down. So I have a number 5, a letter X. So 5 is to the 1, but since that's in the parentheses, it's in the circle, 1 times negative 3 is negative 3. X is to the 1 in the parentheses. 1 times negative 3 is negative 3. So here are my two factors. Now they're negatives, both of them, so they're both go to the opposite side of the line. So is a 5 on top or bottom? It's on top. What's the opposite of top? Bottom. And then the negative 3 turns to a 3. Okay, X is on top. Well, what's the opposite of top? Bottom. The negative 3 turns into a 3. Now, anytime the top is empty, we put a number 1 there. So I have a number 1. Then here are my two exponent factors. I can clone 5. 5 times 5 times 5. Okay. It's 125. So I put a 125 where the 5 to the third used to be. And then the X variable. Really don't clone variables. Okay, my next problem. There's two different dividing lines, so we just extend the dividing line. Now circle your parentheses. That has a power of 3. So any power out of here is times by 3 before I write it down. This parentheses has a 4th power, so any power out of there needs to be multiplied by 4. Any power, if it's on, because the bottom's in the parentheses too. Okay, now on top of the line I have a number 2, a number 3, and a letter X. On the bottom of the line we have a letter X. Well, we already have letter X on top, and we have letter Y, which we don't have on top, so I need to write that down here. Okay, now 2. 2 is to the 1, but that's in the parentheses, so 1 times 3 is 3, and we have 2 to the 3rd power. Now 3 is to the 1, that's also in a parentheses with a 4, so 1 times 4 is 4, 3 to the 4th. Now X, there's two different X variables. Here's the first one. It's 4, but you got to multiply 4 times 4. which is 16. Then my other x is located under the line, so it's a minus operation, but that's also in the parentheses. I circled it, didn't I? So 2SB times by 3. 2 times 3 is 6. And then 16 minus 6 is 10, so it's x to the 10th power. Okay, now here's the only y I have. It's to the second, but that's in the parentheses. The parentheses covers the y. So 2, I can't write 2 down. I have to take 2 times 4. 2 times 4 is 8. So here are my factors. They all appear to have positive powers, so they all stay. Stay, 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 and stay. Okay, so they're all staying where they're at. So 2 to the 3rd's on top, it stays on top. 3 to the 4th's on top, it stays on top. X to the 10th's on top, it stays on top. Now on the bottom, y to the 8th's on bottom, it stays on bottom. Okay, now I clone what I can to further simplify the expression. So 2 can be cloned. 2 times 2 times 2 is 8. So this changes into 8. 3 to the 4th, it's 81. Here, I'll show you. 81. Okay, so that's replaced with 81. And then the x can't be cloned. Well, it can be, but we don't do it. Y to the 8th, don't clone variables. And then 8 and 81 have to be multiplied. Okay? So, because they're on top together, so we multiply them. That gives me a product of 648. That's what we have. 648 times x to the 10th over y to the 8th. Okay, now this one's a little bit tough. The dividing line's here. Now the parentheses covers what's in it. 2 and e with a negative 4th power outside. So the parentheses has a power with negative 4, but it's just this 2 and this e that are in that parentheses. The stuff outside, I don't multiply the power. I just use that power. Okay, so on top of the line, we got 2 times E times G. And then at bottom, I just have an E, letter E, which I already wrote on top, and a letter G, which I already wrote on top. Okay, so 2's to the 1. So it's in the circle, in the parentheses, so I got to multiply 1 times negative 4. That's negative 4. Now be careful on the E. Here's the first E. Now that is in the parentheses, so 1 times negative 4 is negative 4. Then we have a second E under the line, so minus, and it's just a 5. Okay, because it's not in the circle, it's not in the parentheses, it's just negative 4 minus 5. Use your calculator, it's negative 9. So it's e to the power of negative 9. Okay, now G. Here's the first G. That's not in the circle because it wasn't in parentheses, so I just actually write the 5 down. My other G's on the bottom, so minus. But it's not just minus 3, it's minus negative 3. Okay? Put the negative 3 in parentheses, and you have 5 minus negative 3. That's 8. Because if I just put 5 minus 3, that's 2. Okay? 8's the correct exponent. Okay, so here are my factors. Now everything else pretty easy. This is opposite because of the negative power. This is opposite because of the negative power. That's a positive, so that stays. Okay, so the 2 and the E the 2 goes to the bottom because it's on top. The opposite of top's bottom to the 4th. The E goes to the bottom because it's on top. The opposite of the top's the bottom. And then the G stays. It's on top. It stays on the top. So now I have these 3 factors. I don't clone a variable. That stays G to the 8th. Okay, 2 can be cloned 4 times. 4 of them. 2 times 2 times 2 times 2 is 16. Okay, so that is 16. So I replace 2 to the 4th with the number 16. Okay, And then E is a variable. We don't clone variables. So that's simplified as much as it possibly can be. You really need to watch your math with these E and G. 1 times -4 is -4 minus 5. G, 5 minus, and then -3. Okay, scientific notation. This is a 0 here. You can't, the copy machine cut it off. Okay, to take a number into scientific notation, remember what we're looking for. It's blank times 10. Okay. Now, here's my first decimal. I need to move it so it's after the first non-zero digit. So that's 0, 0, 0, 0, 0, 3. Okay. That decimal has to be moved so it's between the 3 and the 5. To do that, it has to go this way. It has to go to the right. Remember, right means the exponent's negative. Okay, so now move it. 1, 2, 3, 4, 5, right there. So point, you got 359. Now count the digits between decimals. 1, 2, 3, 4, 5. So it's 10 to the -5th power. Okay, write the number in standard form. You just take 5.3 times 10 to the power of 7 on your calculator. And it's the decimal ended up right there, so I really don't need to include it in my answer when it's at the end. Okay, but I do want to see commas. 53 million. Okay, then we have a story problem. A recent college graduate, by the way, you're finding the money. Okay. A recent college graduate accepts a job at a law firm. The job has a salary of $32,000. That's the original amount. The law firm guarantees an increase, remember increase means plus, in pay of 3% per year. Find the employee's salary after 5 years. So we have these two units that we need to deal with. Dollars and years. The time is X. The money's Y. Okay? So per, that'd be dollars per year. Okay, now the only thing I see about per year, it's not dollars, instead it's a percent, 3%. Okay, so with the percent, I do my new, or my original, my bad, multiplied by my percent equals new. But since it happens per year, I need a power with the number of years that passed, and it's 5, okay? So it's a power. The other ones, you didn't have to do that because it didn't happen in per year, okay? All right, now 32, so do your percent, 100%, and increase means add, okay? Now it's just basically the same as the other ones, and that's 103%. Divide by 100, and that's 1.03. Okay, now 32,000 is the original amount, and I need to find the new amount. Okay, you just multiply with the caret button. 32,000 times 1.03 caret button, 5th power. Okay, I get 37,096. Now, since it's a money amount, I take the 2 digits after the decimal. 37,096.77. Okay, so remember, it's basically with a percent. When you see percent, you go original times percent equals new, but since it's per year, you need a power on the percent factor. Power depending on how many years. Okay, now polynomials. Okay, we have a plus sign, so no rainbows. Look at your highest power, it's to the second. Okay, so x second, I got a 1 and a -3. Add them. It's -2. Okay, now for regular x's, I have a negative 4 and a positive 13. Add them. But you got to remember 4 is negative. The minus means it's negative. So I got 9. Constants, I have a 6 and a 1. Well, that's easy. 6 plus 1, 7. Boom. Okay, my next one, I have a subtraction operation, so no rainbows. Okay. My highest power here in the whole problem is x to the third. So blank x to the third plus blank x to the second plus blank x plus blank. So x to the power of 3, okay, we have 9. And I don't have anything here for x to the third, so it's like 9 minus 0, which is 9. Okay, x to the second, we have a negative 11 and a negative 6. So I take negative 11 and subtract negative 6. I got negative 5. Okay, x, I got 2 minus negative 3. Gives me 5 again. Okay, then for constants, I don't have anything. I just have the 11. So it's like taking 0 and subtracting positive 11, which is negative 11. And there we have it, simplified. Okay, now the next one, remember the value outside of parentheses means times, so we are going to need rainbows. Now let's make sure every x has a number in front. 3, 8, this would have a 1, 3, and we're good. So now I distribute 3 to 8, 3 to negative 1, 3 to negative 3, and 3 to positive 5. So I just drew 4 rainbows from that 3x to the third power. Remember to put x to the third with your 3. Okay, so the first thing I multiplied by was 8x to the fourth power. And the second thing, negative 1x to the second power. And then negative 3x. And then positive 5. Okay, finding the 4 products. Now 3 times 8 is 24. Then for x, you take the third power plus the fourth power, which is a 7th power. Okay, 3 times negative 1 is negative 3. Then for the x, you take the third power plus the second power, which gives you a x to the 5th power. Okay, 3 times negative 3 is negative 9. Then for the x, you take a third power, and that's a first power. 3 times negative 3 is negative 9, and then x, you take 3 plus 1, which is a fourth power. So you have a 7th, a 5th, a 4th. And then 3 times 5 is 15. And for x, I just have the third power. This factor had nothing for x, so that's just a third. So I have a 7th, 5th, 4th, and 3rd. None of them are the same, so I just write them out with plus signs in between them. So 24x to the 7th plus negative 3x to the 5th plus negative 9x to the 4th plus 15x to the 3rd. Remember to write this out as a sentence with pluses in between them. Okay, you don't need the blanks because none of the powers were identical. They're all different. Making good time here. Okay, now I have 2 parentheses, but no sign in between insinuates multiplication. Okay, so make sure all the x's are covered with numbers. So I start with my 4 and I distribute the 4 to each one of these. So 4 to 1, 4 to negative 7, not 4 to negative 3. They're in the same parentheses. Rainbows don't go across the same parentheses. Okay, so I drew 2 rainbows, 4x, 4x. I'm going to multiply that by 1x and by negative 7. Then negative 3. Okay, 2 rainbows, so negative 3, and by 1x and by negative 7. Now, when we're figuring out these products, make sure the x's have powers. 1, 1, 1, nothing, nothing, 1, and then nothing. So 4 times 1 is 4. Then on x, you add the powers. 1 plus 1 would be a second power. 4 times negative 7 is negative 28. Then on x, you just have the 1 power. Negative 3 times 1 is negative 3. Then on x, you just have the 1 power. Negative 3 times negative 7 is 21. And then you're not even going to have an x, because I don't have an x. I have nothing in either factor. Now, 2 of the powers of the x ended up identical, 1 and 1. So those are like terms. So we need to draw our spaces. So x to the second's the highest, followed by x to the first, which is the same as x, and then the constant. So for x to the second, we got 4. For x, you add these powers, so negative 28 plus negative 3. And negative 31 is my coefficient for x. And then we have 21. Okay, next one. Again, 2 parentheses without a sign means times. Okay? So again, 1, 1. So I have the number there to distribute to. So 1 to 1. 1 to positive 6, 1 to negative 5. So I drew 3 rainbows on that. So 1x, 1x, 1x. I'll be multiplying by these 3 things. 1x to the second, 6x, negative 5. Now I distribute the 4 to each one. The same 3 terms though. Okay, 1x to the second, positive 6x, negative 5. 1, 1, 1. We already have a 2. 1 and nothing. Nothing and 2. Nothing and 1. Nothing, period. So you got 6 products to find. 1 times 1 is 1. Then on x, you take 1 plus 2, which is 3. 1 times 6 is 6. On x, you take 1 plus 1, which is 2. 1 times negative 5 is negative 5. Then on x, you just take a 1. 4 times 1 is 4. On x, you just put 2. 4 times 6 is 24. On x, you just take the 1 that's there. And then 4 times negative 5 is negative 20, and that's a constant. It doesn't have an x. Now look at all your powers. Some of them are identical, like these 2 x's with a second power and these x's with a first power. So we're going to want to make blanks starting with x to the third. Okay, so x to the third, we have the 1. X second, we have a 6 plus 4, and that's 10. Okay, x, you have a negative 5 plus 24. No, it's not 29 because 5 is negative. Okay, it actually goes the opposite way, giving you 19. Then you have your constant negative 20. And this here is my product. The sentence is my product. That's your polynomial. Okay, number 6. Now, when I have a minus or a plus, I need to eliminate the power and make a parentheses of the same. It's called expanding a binomial, but really it's just multiplication. So we need rainbows. So 4 to 4, 4 to negative 3. So 4x, 4x, 2 rainbows, and we distribute it to 4x and then negative 3. Okay, then negative 3, so negative 3 is now the key factor to the same 2 factors, 4x, negative 3. 1, 1, 1 and nothing, nothing, 1, and then nothing. Okay, 4 times 4 is 16. Then on x, 1 plus 1 is 2. 4 times negative 3 is negative 12, and we just got x to the 1. And you're going to get negative 12 again with x to the 1. And then that's 9 without x. Okay, x second's your highest. So blank x to the second plus blank x plus blank. So x second, we got 16. x, it'd be these two. Those are like terms. So I add negative 12 plus negative 12 gives me negative 24. And then my constant is 9. Okay. You're designing a frame to surround a 22 by 20 inch pitch, so that means the middle's 22 by 20. The frame is the same width on every side. So we need to measure the dimensions of the length and the width. Doesn't matter what side you do it on, okay? So mark where the middle stops and starts, both dimensions, okay? So from here to here we know is 22 units, but we don't know the edges, but they're the same on every side, so we can use the same variable x. From here to here is 20, and then x and x. Now, how do you simplify it? There's two x's, so that would be 2x plus 22, and there's two x's here, so that'd be 2x plus 20. Okay, now write a polynomial that represents the area of the picture and frame. So we have a length multiplied by a width. That gives you the area of a rectangle. And we know the dimensions. 2x plus 22 is the length, and 2x plus 20 is the width. So multiplication, we need rainbows. So 2 to 2x, 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 and 2x to 20. Okay, done. And then 22 to 22, two rainbows. That's the same two factors, 2x and 20. So 1, 1, 1, nothing, nothing, 1, and then nothing. Okay, so 2 times 2 is 4. Then on x, we have 1 plus 1, which is 2. 2 times 20 is 40, and then it's just x to the 1. 22 times 2 is 44, which is x to the 1. And then 22 times 20, I believe, is 440. Okay, now some of your powers were the same, so we need to organize it. Blank x second plus blank x plus blank. So x second, you have just the 4. For x, okay, 40 plus 44 is 84. And then you got your 440 constant, okay. Okay, now that's it for part A. Now find the combined area of the picture and the frame when the width of the frame is 4 inches. What that's telling me is that x, these x's, all equal 4. So that means I just replace the x's in the expression down here. So you got a 4. Now empty the x from that parentheses. It is to the second power. And then we add 84. Parentheses, but no power needed. And then plus 440. And we just simply slip that 4 where the x's were. And my calculator will find that for me. So you got 4 parentheses 4 second power plus 84 parentheses 4 no power needed plus 440. Okay, I got 840.